So what is a data container? A data container is basically exactly what the name states it is. It's a container for values, okay? So in our example right here, let's say we hard code this point one, apparently. I mean, we could hard code any one of these. I think in my example, I hard coded the point one to 1.1. But let's say we want to change this to not only, sorry, do 1.1. Let's say we want to change this so that, let's say we want different values, not just 0.1, we also want 0.2, 0.3, 0.4, 0.5. Am I going to keep rerunning that equation? No, right? Remember, programming is here to make our life easier, not more cumbersome. So what I'll do is I'll create a data container. In this case, I'm creating a data container called X. That's the name of the data container. It's you'll hear this term a lot in programming. It's a variable name, right? Basically, what that means is you can name it anything you want. I named it something unimaginative like X. You guys can name it anything you want. Name it Trump, name it Biden, name it LeBron, whatever, right? Whatever you want to name it. Here, I process it. Now look what happened. All right, something different happened now. I processed line 3, like before I command enter, control enter, whatever, what have you. Like before, the command was sent down here to the console. Again, the console is actually the R engine. This is why I downloaded R first, okay? But there's no output here. Like over here, like before when I in line 1, when I processed line 1, I sent it to the console and the console gave me an output. But there's no output now. What's different? What's different is the top right of your screen. In the top right of your screen, all of a sudden, right, the first tab of the top right of your screen says environment. If you click on environment, you'll see this, values x.1. What's going on? RStudio keeps or attempts to keep track of all your data containers, right, of all your data containers. So in this case, we created a data container called X, and bam, it's keeping track of it. There's a data container called X, and it has a value 0.1. All right? Now, how do I use this? Right, in the slide, I basically alternate the equation, right? And I'll alternate it right here. I'll copy this, put it down here, and now instead of 1.1, I'll do x1 plus x, copy this, 1 plus x, 1 plus x, and 1 plus x. All right, I run this. Now again, look what happened. Line 4, it was sent down here, but this time it gave me an output. It gave me the same output, right? Why did it give me the same output? Well, because PEMDAS is kicking in. Remember, guys, remember PEMDAS from algebra? Right? Here it says, okay, 1 plus x. What is x? X, it knows, is a data container with the value 0.1. Therefore, this is equivalent to saying 1 plus 0.1, which gives you 1.1, which turns into the same equation up here. You can use these data containers directly to do math, right? Directly to do math. Okay? Also, notice the difference here with the single equals. The single equals creates the data containers. When you have a single equals, and this will be a running theme throughout the semester, when there is a single equals, you are either creating or you are transforming a data container. I'll say this again. When there's a single equals, you are either creating or transforming a data container. If you want to know what's in the data container value, again, it's in the top right, or you can simply just type the data container all by itself and then process it. And down here, you'll see that it gave you, it sent the x down here, and it gave you the value 0.1, because that's the value of x. That's the value of x. So this is how data containers are used. They're used as substitutes of our mathematical equations. Now, why does this come in handy? Well, let's say we wanted to run this equation, but instead of x being 0.1, we wanted x being 0.2. Do we have to rewrite the equation? So rewriting the equation is not that big a deal. There's only 4 parts that have to be changed anyway. Here, 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 and here. But instead of a 4-part equation, what if we had a 40-part equation? Are we going to change 40 parts? Of course not. Right? You write it once, and now we can change the value. Let's say I want to change it to, instead of the math being multiplied by 1.1, I want to be multiplied by 1.4, hypothetically. All right, so what do? I change the value of the data container. X equals 0.4. Sorry, 0.4. I process it. It went down here, but there's no output down here. That is because a single equals was used. And when you're using a single equals, a data container is either being created or transformed. And if that's the case, the results are sent up here to the top right window. And there you can see automatically X has been transformed to 0.4. And now, I don't have to rewrite this equation. I could just run it at this point. Boom. And you see it's been sent down here, and the value is completely different because now we're doing 1 plus 0.4 as opposed to 1 plus 0.1, right? It does not matter, by the way, that this line precedes this line. It does not matter. What matters, right, is when we're running a line, at that moment, what are the values of the data container? Because this line 4 we ran at this moment, right? At this moment, the value of the data container X is 0.4. That's all that matters. Whenever we run a line that has data containers in it, right, all it's going to do is it's going to look at what the current value of those data containers are and then do the math and give you the output. Bam. So that's basically a data container right there. That's a data container for you. And that is, again, right here, that's basically behind the scenes what's happening here. So when you create that data container in the top right window of R, a piece of your memory, think of like your memory like an Excel sheet. So if your memory in your computer memory is like an Excel sheet, a cell in your memory, one particular block, is being named X, and in that cell, the value 0.1 is going to be placed, right? So that's basically the way these data containers work behind the scenes. A chunk of memory is given a name, okay, and then values are put into that memory. So like you want to think, again, you want to think about it like Excel. In this case, a cell of Excel would be named X, and it would be given the value 0.1, right? And again, these are variable names. Data containers could be any name you want, and they are case sensitive. They are case sensitive. A lowercase x is different than a uppercase x. So that's important. That's important to remember. R is case sensitive. And I like doing this because I like some of my old students, my ex-students, if anybody had me in the other classes, they'll see this image, right? It's very familiar. I like to liken in R these data containers to a bookshelf, okay? So in this case, the book is the value 0.1, and the bookshelf itself is X, right? And the reason I use this analogy is because in the world of R, unlike Python, the most simplest data container is actually what we call a vector or an array. That is the simplest building block in R. Now, this is different than Python. In Python, you have data types. You have those vector and array data structures, of course, as well as advanced ones, just like you do in R. But you also have what we call primitive data types in Python. Not so in R. R's basic building block is a vector. Its basic building block is a vector. So what happened is when we defined X right here, like we did here in line 3 and line 6, when we defined X, we essentially created a bookshelf with just one level. It was just it's a bookshelf that only has one shelf on it. And in that shelf, we put the value 0.1, right? So, and I'll use this analogy of the first couple of weeks, that the vector is like the bookshelf. And that's what X is. The X is basically an array or a vector of size 1, right? Or if you want to think of it like a bookshelf. Now, Given that X is an array, given that X is essentially a bookshelf with values in it, now I introduce this syntax to you, right? This bracket 1 bracket. Not to be confused with what's going on here. Don't confuse that with this. This means something completely different. I will, as our calculations get a little more complex, I will show you how this is more of a placeholder. So like I said before, when I just process X, you get the value 0.4. All right, done. But now, if I do something like this, and this is something exclusively of data containers, be it a simple one or advanced one, doesn't matter. I introduce an open bracket and a closed bracket, right? See that? Right next to the data container. Now what's happening? What am I doing? And let me place a 1 in there. Okay, what is this syntax? What is it saying? This open, because of the fact that X is a vector or a bookshelf, this open bracket, closed bracket, basically is saying, hey, this is the shelf that I want to look at. So let me say that again. This open bracket, closed bracket, basically is saying, hey, go to the bookshelf named X and go to, open bracket, closed bracket, go to the first shelf in X. Tell me what value that is. And when I process this, it gives me the value 0.4. Why? Because, like I said before, the most basic building block of R is vectors. When you create a single value vector, a single value data container, like we did in line 6 and line 3, you're creating essentially a vector. But it's a vector of just one value, or it's a bookshelf with just one shelf in it. So when we process line 7 and say, hey, show me everything in that data container, bam, it gives you 0.4. When I do line 8, I'm saying, hey, go in there and give me the first shelf value of X, it gives me 0.4, right? Because X is only holds a single value, therefore its first shelf value. I mean, the only value, the value in its first bookshelf is 0.4. Okay? Now, if that's the case, what if I attempt to look at the second bookshelf value for X? The second bookshelf value for X, or the second position value for X. What if I attempt to do that in line 9? Bam, NA, not available. R is basically like, I don't know what you're doing, but there's no other values. There's no other shelves. X is simply a one shelf bookshelf. There's no second shelf. There's no third shelf. There's no 30th shelf, right? It's all NA. It's just got one value. Just got one value. So again, that is because, to stress again, the basic building block of R is arrays and vectors. X is essentially an array or a vector. However, I will use that term interchangeably. Vectors and arrays, I mean the same thing. Arrays is more obviously from programming. Vectors is a syntax from linear algebra. For any guys that took linear algebra or any kind of numerical analysis mathematical class, that's where that term vector comes from. All right? So, given that, let's change the vector up around a little bit, guys. So here, right, I have a value for x1. Done. It tells me the first value of x1 is 0.4. All right, done. And again, if I do the second shelf, it's NA. But let's say I want to create a second shelf for x, or I want to create a second position in x and put a value in there. How do I do it? Well, again, R is very, very flexible. It's very, very easy, very, very flexible. You just simply do it on the fly. So here now I'm saying, okay, in the second level, second shelf of x, or second position of x, put the value, what do I say here? 5, 6, 7. All right, put the value 5. Boom. Line 9 was sent down here. No output. Again, ladies and gentlemen, why is there no output? Because there's a single equals there, and when there's a single equals there, you're either creating or transforming a data container. And when that happens, there will be no output here. The output will be up here. Now look what happened up here. Now you have this new syntax that says num for number. It has a bracket 1:2, close bracket, basically saying, hey, there's two values in here. And say two value now vector, and it's basically showing you the values there, 0.4 and then 5. Wild, huh? Now if you were to process X, the whole data container, now, ladies and gentlemen, look what happens. You don't get a single value back, you get all the values in the bookshelf back. Well, you were always getting all the values in the bookshelf back, it's just that there was one value. In this case, there's two values now. Boom. You get the 0.4 and 0.5. In fact, let me go ahead and do for, all right, 6 and 7. All right. Boom. Now I type in X. Ta-da. Right? 4, 5, 6, 7. It gives you all the values in bookshelf, but in the bookshelf. But again, if I just want a particular value in the bookshelf, let's say the second value, boom, it'll be 5. Or the fourth value, boom, it'll be 7. Do you see? This is what these square bracket syntaxes are. And I know some of you guys have probably Googled or messed around with R, or even NumPy in Python. And you're like, what is this stuff, right? This is essentially what it is. You're looking at particular values within the array or the vector. Or in this case, you're looking at a specific bookshelf or a specific shelf within a bookshelf, right? And grabbing that book or grabbing that value. So that's what's happening right here. And ladies and gentlemen, now you have a vector of size 4. Now you have a vector of size 4. Now, you can go back. This is pretty fluid. Hold on. You can go back. This is pretty fluid, right? As you can see, I can change any of these values that I want. I can go back and change the first value. Again, if I just do this, it'll give me the output of the value. But if I throw a single equals in there, now I'm transforming. If I do 22, boom, output goes up there. You'll see it's changed, and now the first value is 22. All right, so this is one way to create a vector. Again, a simple data container in R. But we have multiple other cool functions that we can use to create vectors. And I'll show you some of the basic ones. And we use these ones over and over again. So this is why I showed this. By far the most versatile function, and the function you will probably use the most, is the C function. Now, you hear me saying a term called function. For those of you guys new to programming, what is essentially a function? A function is basically something with some sort of name. So let's assume, for example, there's a function called apple, right? So it would have a name of some sort. It would have an open parenthesis and a closed parenthesis. Anytime you see some sort of name and then an open parenthesis and a closed parenthesis, you're using something called a function. All right, now what is a function essentially? A function is an abstraction of code predefined somewhere for your use, right? For your use. So, for example, a very famous function in R is the C function. For my Python students, this is equivalent to using the double brackets in Python, the double brackets in Python. So we don't have double brackets here, we have the C function. So in this case, it's a very simple function, C. Here's your open parenthesis, here's your closed parentheses. And anything that goes between the open and closed parentheses of the function is what we call parameters. And those parameters are used by that function, passed on to some code, and then something happens behind the scenes. In this case, the C function basically creates vectors, right? It creates a vector. So in this case, I'm creating a vector called A that's going to have 5 values, 45, 2, -8, 10, and 1, right? And instead of just doing this, A1 equals, what is it? Sorry, 45, 2, -8, 10, 1. Oh, first I have to create the object itself. All right, A is 45. Now A2 equals 2, -10, and 1. And the 1. All right. By the way, just to show you, I can run all these lines of code. If I just highlight this, I can run all 4 lines. And you can see it was passed down here and processed. No output because obviously they have a single equals. And but you can see the output right here, right? So here, I created this vector called A that's going to have the values 45, 2, negative 8, 10, and 1. Now, instead of doing lines 17, and 21, I could have used a function that would do those commands for me automatically, right? And that, ladies and gentlemen, is the Seq function. 45, comma, 2, comma, negative 8, comma. The parameters are always, within a function, are always separated by commas. 10, comma, 1. Execute this. And ladies and gentlemen, line 23 does exactly what line 17 to 21 did, right? And you can create a vector of any size you want. You can have one value in there, right? You can literally do A equals C, parenthesis, open parenthesis, 45, close parenthesis, and bam, you create a vector of one size. Or you can create a vector of size 100. It does not matter. You have that flexibility in an R. All right? Another way, cool way to create a vector is the colon. And you'll see us doing this all the time. So here, if I do 1 colon 5, what's happening here? I'm creating a vector that's basically 1, 2, 3, 4, 5. Sweet, huh? Right? So it's basically going to start with the first number to the second number and go 1, 2, 3, 4, 5. Now, real quick, I went over this. I did this really quick without stressing this point. When you guys saw up here, again, if I do b of 1, it gives me the first value of b, right, which is 1. You guys notice something different about R than any other programming language? My BAPC, my business analytics students should be on top of this. The first position starts with the number 1, not 0, like in Python and every other programming language. Here in R, the first position is literally the number 1. Why not 0? The answer is very simple. R is written by human beings for human beings, whereas every other language is written for machines, and we just have to live with it. This is why I love R, right? It's much more intuitive. It's much more intuitive. All right? So I just wanted to stress that point. So again, line 25, 1 colon 5 literally says 1, 2, 3, 4, and 5. Now again, for my Python students, my business analytics students, look after the colon. That 5, it's not exclusive anymore. It is inclusive. Why? Again, R is written by human beings for human beings. All right? Very different than Python. Well, not very different than Python, but more intuitive than Python. Right? So there we go. 1, 2, 3, 4, 5. And if I create another variable, b2 equals, and let's say I do 5 colon 1, what's this going to be, guys? Same thing. 5, 4, 3, 2, 1. Just goes the other way. All right? It just goes the other way. Are we having fun yet, guys? Huh? Not bad, right? All right, the next function, the REP function, repeat function. So here, first of all, I apologize. I created an array called C. I don't want you guys to be confused by the C function. So let me call this something else. Let me call this C2. So how does rep work? Rep stands for repeat. So here, if I do repeat 3 5 times, right, it literally is going to repeat 3 5 times, right? I could do repeat 3 10 times. It'll repeat 3 10 times. So this is a way to create a vector of the same number or value for whatever X amount of times you want. Yes, sequence. Now sequence, SEQ, this function stands for sequence. Now sequence is like colon, right? It's like the colon function, except it's a little more powerful. So here what I do. Okay, 2, 10, 2. All right, excellent. So here let's do, all right, anybody want to take a guess what's going to happen here? Whoever answered, you're correct. This is going to create a vector starting with the value 2, ending with the value 10. My business analytics students, 10 again is inclusive. You're back to normal world over here, all right? 10 is inclusive, so it's going to start with 2, go to 10 in steps of 2. All right, so it starts with 2, goes to 4 plus 2, goes to 6 plus 2, goes to 8 plus 2, goes to 10 plus 2. All right, this is how you can create sequences that are a little more where you need flexibility in the stepping. Right? And you can go the other way as well. If I create another sequence, let's say I want to go from 1 to 5, but this time I want to do it in increments of not like 2, something greater than 1. I want to do an increment of, let's say, 0.1. Right? And now it'll literally do that for me. 1.1, 1.2, 1.3, 1.4, 1.5. Yeah, blah, 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 all the way to 5. All the way to 5. Right? Very cool. Very cool. All right? Comes in handy again if you do want to do simulations, certain kind of simulations. Alrighty. Now here, I apologize. Here, this is a typo, guys. Just ignore this down here. Now, do this. Here is a little test for you guys. Can you tell me? I mean, it's not that much of a test. I give you the answer down here anyway. But can you, without looking at the answer below, tell me what vector E is going to be? All right. Now let's break it down. Firstly, understand outside here we have the C function, right? You guys see that? There's a C function, all right? That is not that difficult. I showed you what's going on there. The curveball I threw at you guys is I have within the C function, I have these other functions. I call these other functions, including another C function. It's okay. It's all right, right? Go inside out. In R, you can call functions within functions within functions. You'll see some crazy stuff, okay? But just take it step by step. And what does it mean by taking it step by step? Go inside out. So in this case, right, this right here becomes a vector 3, 2, 1. All right? This becomes a vector 3, 3. This becomes a vector 1, 4, 7. And this obviously is just going to be the vector 2, 4, 5. Okay? Now you might be asking me, okay, but how does the C function deal with the fact that it has numbers and vectors within the parameters? Well, what C will do is it will just simply take the numbers from those vectors and include it in its one giant vector. Okay? So no matter what C will do is it will create a vector. If it has vectors inside it, it'll just simply just take those values and include it in the giant vector it's making. So that's why we end up with this giant vector where the first value is 55. That's not bad. 27. That's not bad. We get to our first function, which I said was 3, 2, 1. So there it is, 3, 2, and 1. We get to our second vector, which is 3, 3. There it is, 3, 3. We get to our third one, which is 1, 4, 7. There it is, 1, 4, and 7. And then we get to the last one, which is 2, 4, 5. And there it is, 2, 4, 5. And that's how we get one giant vector that is named D, that is 55, whatever, these values. All right, very good. For everybody that got it, very good. Excellent. All right, so now let's get into something called for loop statements and if-else statements, right? Constructors. Conditionals, what we like to call conditional loops and if-else statements, all right? This is something in every programming language, okay? my BAP students, the syntax is different, but you pretty much get the gist. Okay. This is the basic skeleton of an if-else loop. This is the, if you want to call it, the visual representation of what's going on. If-else statements is how programs can make decisions based on certain value, right? That's basically what if-else statements are. They're like a fundamental building block of every programming language. All right, and look, I'll explain it for my newbies. I'll explain it here, but you're really going to get a feel for this once you do a couple questions in the practice sets. All right, but nevertheless, try to try to understand, but don't be intimidated if you're like, what is going on over here? You have to really see this in application. But nevertheless, this is the basic syntax of an if-else condition. And within the you have these keywords called if and else. You have something called a squiggly brace, right? You got to open, close there, open, close here. And then you have parentheses. Within the parentheses of the if statement goes the condition, all right? It's some value you're checking, okay? If this condition ends up being true, then what happens in the first squiggly braces gets executed, and whatever's in the second set of squiggly braces gets ignored. You see? Only one set of code, either line 2 or line 4, will be executed. That's what that expression 1 and expression 2 stand for, lines of code. It could be one or many, it doesn't matter. So anytime you use an if-else statement, either this set of code will be executed or this set of code, never both. Never both. The analogy I always like to use is ladies, you always have plenty of suitors, especially my analytics students, right? People are going to try to use you for your analytics knowledge. You'll have many suitors, but you can only marry one, right? That's basically, at least in the state of New Jersey, you can only marry one. So you can only choose one or the other. This is the visual representation right here. You check the condition to see if it's true. If it's true, this particular block of code will be executed. If not, this code block will be executed. And then after that particular block of code is executed, all the rest of the code will be executed. So any code after these squiggly braces will automatically be executed. It's only in these squiggly braces, one or the other will be executed. All right, so here let's do an example. I create a variable called quantity, a data container called quantity. I give it the value 25. And this is my if-else right here, guys. Here's my if-else right here. All right, so I say if quantity is greater than 20, this is the condition within the parentheses. So it's testing to see if quantity is greater than 20. Now, what is quantity? Quantity is literally the value 25. Is 25 greater than 20? It is. Therefore, this line of code, and this is a print line, it's going to just give you a print statement, will be executed, and this will not be. Right? So let me just copy and paste this. This is going to be ugly. All right. All right, so here we go. I have a whole mess of errors. Let me address this. This quote is the wrong quote. And this quote is the wrong quote. And I still have, looks like everything else is fine. Let me move that up there. Sometimes, guys, when you have an if-else statement, you'll get an error. Like it's giving you an error like that. See on line 42? It says unexpected token else. Just in that case, just move the else up to the last brace. So here's the opening brace right here. I like to move, I mean, there's no tabs in here like in R, right? And I'm sorry, in Python. But I like to always tab things accordingly just so it's easier to read. So in this case, when you get that error, just move the else up to the same line as the closing bracket for here, and that error will go away. This is something relatively new in R. For some reason, they don't like else all by itself. They want it to be connected to this one immediately like that. I think they're doing just to enforce when you have like multiple if-elses. You'll see that later on. So there you go. I ran all these lines, and make sure you run all these lines because it's an if-else statement, and you get the output you sold a lot. Excellent. Now, here is a little tip for you guys. Let's say I did this. Let's say I just highlighted a part of this and I ran it. You'll see something like this down in your console. You see this plus? Some of you guys probably are already seeing this plus. And you keep pressing enter and you're like, oh my God, what did I do? I should drop out of this class. What's going on? Okay. Basically, this plus means that R is, you gave R a partial command and it's waiting for the rest of the command. Don't panic if you see the plus. Simply just press escape. Right? Just press it once, or I think 2 or 3 times, and boom, you're back. You're back. So anytime you see these pluses down here in these consoles, you gave a partial command and it's waiting for the rest of the command. Just get out of it. Just press escape a couple times and you're good to go. All right? So that's basically the if-else statement. That's basically the if-else statement right here, right? And of course, before we jump into the for loops, let me just change the value of 25 to be now 19. All right, and let me run the if-else statement. And you'll see now that you get the different result. Not enough today. Why? Because quantity was now 19. So this is false. If this is false, whatever's within the squiggly brackets right below it will not be run. And just the else part gets executed, which is not enough for today, right? It's that simple. All right, now let's look at the for loop. And the for loops and if-else statements tend to be used together hand in hand. So what does the for loop do? The for loop basically allows you to run the same set of code over and over and over again. Let me give you an example. So here I jumped in and I did some codes and I did some for loops, and I'll show you guys in a second what this stuff means, what the output is. But basically what the for loop is doing here, this is the keyword for for loops, all right? Again, you have a parentheses, a for keyword, parentheses, and squiggly braces, okay? The for loop allows certain code to be run over and over again. Think of it like a function that you want to run a certain amount of times. So the way it works is, sorry, there's also a keyword called in within the parentheses. To the left of, let's start off with the right. To the right of the n, you're going to give some sort of vector, right? Doesn't matter what it is. You can predefine it or define it directly in here. So let's say I give the vector 1, 5, right? Which again, you guys know is 1, 2, 3, 4, 5. Done. So to the right of n, you give a vector. To the left of the n, you give some sort of variable. In this case, I'll choose a variable I. That variable, it's called, formally it's called an iterator. And what that does is it literally iterates through the vector to the right of the n, which is 1, 5. So what's going to happen now is this for loop will run for as many loops, okay, for as many loops as there are values in the vector or array we specified. How many values are there in this vector? 5. 1, 2, 3, 4, 5. Therefore, this for loop will run 5 times. And every time it runs, it will execute whatever code is in those squiggly braces. So let's do something simple. Let's do a print. Print I. Okay? Now, where does the I come in here? Where does the variable that's to the left of the in to the in come into play? This comes into play every iteration of the loop. There's going to be 5 iterations of this loop. In every iteration of the loop, I will take on a different value in this vector. So first, I will be the value 1. Then the I will be value 2, in order, by the way, in order of this vector. So the first value will be 1, second value will be 2, third value will be 3, fourth will be 4, fifth will be 5, right? So now if I run this, as you can see, I have the values, what was printed out, 1, 2, 3, 4, 5, in that order. Now, if I were to change the vector up a little bit, Let's create a vector. We have a vector A, right? Yes, excellent. So we already predefined a vector called A that has the values 45, 2, -8, and 10, and 1. If I were to do, instead of 1 for I in 1 colon 5, instead I do for I in A, again, A is a vector. I will simply iterate through every value of A. There are 5 values in A. Therefore, the for loop will run 5 times. And each time it runs, I will take on a different value in A. Right? So now if I run this, all right, you'll see the first loop, I took in the value 45. Second loop, I took in the value 2. Third loop, I took in the value -8. Fourth loop, I took in the value 10. And the last loop, I took in the value 1. You see that? And that's basically how we iterate through these vectors, right? This is the for loop. Now, given this, basically this is essentially at the basic level what the for loop is doing. What's happening here? All right, now what's happening here? All right, so here I'm getting slightly fancy, but it's nothing you guys can't handle. All right, I'm getting slightly fancy, but it's nothing you guys can handle. So in line 1, I'm creating a vector called 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. In line 2, I'm creating a single value called CNT that's going to have the value 1. All right. And here in the for loop, I have an iterator that I named wall. Now again, the iterator is a variable name, just like our data containers. They can be any name you want. So I chose the name wall. All right. Well, the variable wall will iterate through the array called A, which again is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And now here, what's happening here is that in this line of code, this might be a little too intensive for you guys, but again, just take it step by step. Now, look, there's a single equals there. All right, there's a single equals there. What does that mean? Remember, we are either transforming or we're either creating or transforming a data container. In this case, we already have a variable A, we're transforming it. So in this case, there's an order of operations to the single equals. You always do the right side of the single equals first, and then you do the left side. So here we have a single equals. We're going to do the right side first, and then we're going to do the left side. So in this case, what is wall? In the first loop, what is wall? Wall is the value 10. Okay. What's 10 plus 5? 15. Excellent. So the right side of the equal has the value 15. We want to set that value 15 equal to whatever is the CNT value, right? Because here now we're not giving a number within the square brackets. Here we give a variable named CNT. So the question is, what value is in that CNT? The value is 1. So basically this is saying, okay, cool, I want to put the value 15 in the first shelf of A. Done. You see that? That's how we break down and decipher it. We did the right side first, we got the value, and then we said, okay, put that value into whatever position of A this is implying, which is implying the first shelf. So now we just changed the value of A. A's, at least the first value of A. The first value of A is now 15. Okay? We come down here to line 7, because again, everything within the squiggly braces must be done, each loop, each iteration. And now CNT is changed to what? Again, look at this. I got a CNT here, I got a CNT here. What are you going to do? Don't panic. Single equals. We are creating or transforming a data container. If that is happening, that means we do the right side first, and then we do the left side. So here, I do the right side first. I do CNT plus 1. What is CNT as of right now? CNT is still 1. 1 plus 1 is 2. Okay? CNT is now going to become, we're setting the value CNT, the data container CNT, equal to 2. CNT will now become 2. We just increment the CNT. All right? And now the first loop is done. And now, wall can move on to the second value in A, which is now 9. And the whole shebang happens again. the whole shebang happens again. In fact, here, I kind of diagram for you, right? So in the first loop, the first value becomes 15. In the second loop, loop 2, the value becomes 14. The second value becomes 14. In loop 3, wall becomes 8. CNT equals 3. Sorry, wall is, after loop 2, wall is 9. CNT is 2. But now the third value becomes 13. These variables change to 8 and 3. And now we have 12 in the fourth value. Wall becomes 7, CNT equals 4. 11 becomes the fifth value. Wall becomes 6, CNT equals 5. 10 becomes the sixth value. Wall becomes 5, CNT equals 6. 9 becomes the seventh value. Wall becomes 4 and 7, and CNT equals 7. And I basically stop from there. I basically stop it at that point. All right. And so I mean, you can go all the way to 10 and see what the basically confirm what the values are, or you can basically just type it into R and you'll see what the values will be. But that's basically how we interpret the code. Now here, I have some two other functions that I wanted to introduce to you guys, and these functions come in handy all the time. Capital N row, all caps, and length. To a vector, they do the same thing. If you put a vector, again, these are functions, predefined functions, okay? If you put a vector within their parameters, all right, all it simply does, it tells you the length of the vector, how many values are in the vector. So in this case, A has 10 values in it. This is going to give you the value 10. This is going to give you the value 10, all right? So as an example, I currently have an A that has the values 45, 2, negative 8, 10, and 1. If I do n row A on this, it's going to be the value 5 because there's 5 values in A. And length will do the same thing. All right. When it comes to vectors, they're interchangeable. They do the same exact thing. All right. And here, now I'm using a couple of functions all wrapped in one. You know what 1:5 does. 1:5 will give you the value vector 1 through 2, 3, 4, 5. But within the colon, using the colon methodology, you can also use other functions. So here now, we have to go inside out. First, solve this before we do all of 1 colon whatever. First, solve this part, okay? What is this going to be right here? N row of A, in this example. N row of A is, like I said before, is 10. So this literally simplifies to 1:10. What will 1:10 give you? It'll give you a vector of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So V will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I leave this for your example for you guys to do right here and get the answer here. What's going to happen here? All right. So this part I'll leave for you guys. All right, we did this. And now let's tackle this for loop. All right. Here now we combine. Did we do this? Excellent. So here now we combined for loop with an if-else statement. All right. And now, how is this going to look like? So what I want to do here is I'm going to do this example for you guys side by side in Excel. So let me just, not in Excel, I'm just going to show it to you guys in a way that you guys can see it. So let's see my Excel. Just opening up my Excel right here. Alrighty, so here, let me minimize this. Okay, I'll make this bigger in a second. Give me a sec. Let me move the Excel over here. Alright, give that that. Give that, make that bigger, see? There you go. Let me make this bigger. All right. And here we go. All right, now, B equals 1:5. So what is B? B is going to be a vector of the values 1, 2, 3, 4, 5. Done. All right. Now I have a for loop with the iterator named Janice. I don't know why I named it Janice. I think Friends was on or something. And I'm going to iterate through the vector 1 colon n row b. All right. So Janice will be an iterator, right? That's a variable. And it's going to iterate through this array, whatever the heck this is, right? And we won't panic, right? Again, like before, we'll break this down into whatever. Dynamically, I'm creating a vector, so dynamically we'll figure out what this is going to be. So n row of b is what? N row of b is going to be 5. Because it's basically asking how many values in b. We have 5 values in b. So this translates into 1 colon 5. So Janice is going to iterate through what? It's going to iterate through a vector that is literally just, it's the same thing as b, 1, 2, 3, 4, 5. All right. So now let's start it off. Loop 1, the first loop. Janice has which value, guys? It has the first value of 1, 2, 3, 4, 5. So it's going to be 1. Excellent. Now we do the first condition. We jump here and we jump in and we do the first condition. What is the first condition? Okay, what is the first condition? The first condition is asking, is b of Janice less than 3? What is Janice? Janice is 1. So this says if b of 1 is less than 3. What is b of 1? b of 1 is 1. Is 1 less than 3? Yes, it is. Therefore, we execute this line of code right here. This line of code translates into b of Janice, Janice is 1 right now, equals b of 1, again, that's Janice, plus 5. All right? And remember, single equals, we do the right side first. What is b of 1? b of 1 is 1. 1 plus 5 is 6. Therefore, b of 1 will now equal 6. And up here, the first value of b now got overwritten to be 6. All right, now we're done. This line of code totally gets ignored because remember, only one or the other happens. And so now we go to loop 2. All right, in loop 2, Janice now takes on the value 2. We come to this condition again. Is b of Janice less than 3? Janice is 2 now. B of 2, is b of 2 less than 3? The second value of b is 2. Is 2 less than 3? It is. So again, we're going to execute line 7. Again, I will simplify this. B of Janice is b of 2 equals b of Janice, which is b of 2, plus 5. We do the right side first. What is b of 2, guys? B of 2 again, become a pair. It's 2. So I do b of 2 equals 2 plus 5, which is 7. So now the second value of b is being overwritten to be 7. All right? And again, we don't do this else line right here. It's only one or the other, guys. Loop 3. Janice now becomes the value 3. All right? I come here again, check the condition. B of Janice less than 3. B of 3 less than 3. What is B of 3? B of 3 is 3. Is 3 less than 3? It is not. I skip this line of code and I go straight down here and I'm going to execute this. And again, I'll simplify this. Now it's going to be b of Janice, which is 3, equals b of 3 minus 5. Sorry, minus 5. What is b of 3? It's 3. If you look in the cell A1, cell A1. 3 minus 5 is what? Negative 2. So this becomes b of 3 equals negative 2. All right, come up here, make the appropriate change, and we move on to loop 4. Okay, Janice now equals what? The next value, which is 4. All right, I come here, check again the condition. B of 4, is b of 4 less than 4? What is b of 4? The fourth value of b is 4. Is 4 less than 4? It's not. We skip this, come down here again. And again, this is going to be if b of 4 equals b of 4 minus 5. All right, what is b of 4? b of 4 is 4. Therefore, this simplifies to is b of 4 equals -1. Just basically saying, hey, the fourth value of b is now going to become -1. Right? Oops. And now, ladies and gentlemen, we are finally at the last iteration of this for loop, the fifth loop. Janice now has equal 5. If b of 5 less than 3, what is b of 5? b of 5 is 5. Is 5 less than 3? It's not. This is false. I can come here and do this. So this becomes b of 5, right, equals b of 5, right, minus 5. What is b of 5, guys? Again, it's 5. So this translates into, this simplifies into b of 5 equals 5 minus 5. So this last value now becomes, guys, 0. All right. And that's how, after everything is said and done, the for loop, basically b got transformed from 1, 2, 3, 4, 5 to 6, 7, -2, -1, and 0. And that's basically this for loop right here. All right. Now, those are the for loops. We want to get into, now I showed you how to use if-else statements and for loops. Now, yeah, even though I show you guys this and I test you guys on this, we actually, in the world of, whether you're doing Python, NumPy, or in the world of R, we tend to avoid these if-else statements and for loops because we have a concept called vector mathematics, and we interpret the for loops and if-else statements in the world of vector mathematics. In fact, vector mathematics in the world of R, and obviously in NumPy because it ripped off R, it's very powerful. And it's the primary reason why we use R and Python for data science.